Hello and welcome to the YouTube channel D Creations Resources. We are looking at research methodology. Now, when you collect data, the next step, of course, is analyzing it to get some meaningful conclusions. So, this data analysis is kind of a transformative process, and some measured quantities are taken and then they are processed and transformed in some other values. Now, every measured quantity is going to have two parts. One will be the value, and the second will be an uncertainty. Because when you do an experiment, there is a room for uncertainty. Let me give you a simple example. Suppose the experiment is measuring of heights, and you are measuring the heights, but that time if you forgot to tell the people to remove their shoes, then there is going to be some error, right? Or if the people are not standing straight, then that will also lead to some error in the value. Or suppose if you are measuring weight, and if you have not taken into account that the person is also holding something heavy, then obviously that error is also going to be incorporated on the weighing balance. So this is a very trivial example, but even in all the experiments, for example, there's this experiment where you need to measure time using stopwatch. So it depends on whether the stopwatch is accurate, because you know there are different kinds of errors, measurement errors. So there can be systematic errors or there can be random errors, and such errors lead to some uncertainty. Now, one would ask, how many digits do we keep in our experimental values? Well, for that purpose, we need to know about significant digits or significant figures. So, what are these? Significant figures or significant digits are the meaningful digits or the meaningful figures in a number. And there are some conventions which are followed in order to find out which are the significant figures. For example, a non-zero digit is considered significant in a number without a decimal place. So for example, if the number is 17, both 1 and 7 are significant digits. Or if the number is 7.432, then it has four significant figures. Now, zeros between non-zero digits are also significant. So, if the number is 1054, even if the digit is 0, it is still significant here. What about the zeros to the left of the first non-zero digit? For example, if the number is 0.019. Now, in this, the only two significant figures are the digits 1 and 9, because 0.019 can be written as 1.9 into 10 raised to minus 2. Now, for numbers with decimal points, zeros to the right of the non-zero digit are significant. So, if you write it as 3.00, then there are three significant figures. And if you write a number as 0.040, then this also has two significant figures. Now, for numbers without decimal points, the trailing zeros may or may not be significant. So if the number 900 is to be written, it can be written as 9 into 10 raised to 2. So there's only one significant digit, namely 9. There are rules to express the uncertainty associated with a number. So let us say that the number is 7.82, and the uncertainty, if you are trying to say that it is plus or minus 0.023894, this is meaningless, because your original number had only two digits after the decimal point. So the uncertainty should also be plus or minus 0.02. That's all. So to put it in words, the last significant figure in any result should be of the same order of magnitude, that is, in the same decimal position as the uncertainty. And the uncertainty should be rounded to one or two significant figures. To give you another example, consider the number 8.0. Now here, if you are expressing the uncertainty, Instead of saying 8.0 plus or minus 3, you should be saying 8.0 plus or minus 3.0. So that the number of digits after decimal places in both the number and the uncertainty are same. Now if you are trying to add two numbers, and if there are different number of significant digits, the answer must be expressed with only the proper number of significant figures. So after addition or subtraction, the result is significant only to the place determined by the largest last significant place in the original numbers. Let me give you an example. Consider the number 57.332 plus 1.1. Now here no point in giving the answer as 58.432. It has to be rounded to get it as 58.4. Consider two numbers, 2.80 and the other number is 4.5041. Now here, which is the number with the smallest number of significant figures? It's 2.80, right? So the answer also should be rounded off to 12.6 because 2.80 has three significant figures and 12.6 also has three significant figures. So instead of writing it as 12.6 followed by some digits, it has to be rounded up. So this is the significance of significant digits in data analysis for research. Thank you.